All right, so inside here, this is the part we made a press fit for. So this is a press fit. Right now it's too tight to go in, just starts. And there's a relief. This press fit region goes back about 0.6 inches. But I need this to actually stand proud above that. So I need to reduce this press fit lip here to something that's just a little bit smaller than this right here. And to find out what the depth is, I'm using this groove mic, which works backwards from how you'd normally think. And it kind of looks like it's around 0.610. And if I remember right, I made this guy around a half. It was a rough estimation that the guy who gave me the project had already marked it on the part. So I just used the lines that he had there. .503. Boy, he was really close to 0.5. That's pretty amazing. So we got to come in about 100 thousandths. So we're just going to take off the inside of that for about 100 thousandths. And that should be good. So this little lip here is just to align the press fit anyways. It's going to be welded on. But on top of this guy is going to sit this guy. So when this gets pushed in, this washer needs to sit above that lip. So this part's going to ride on top of it. This bronze washer here is the friction surface. So I need to make sure that this lip here is smaller than the width of this, so that this stands proud, because the washer does not fit in this diameter right here. So now we've got the part flipped around, and we want to bore this side out so that this will fit inside. Not press fit, but snug, because that's used to adjust timing. And we're going to go in a little deeper than this because there's going to be a spacer, and this inside is just relief anyways. So we're going to go in this diameter, but a little bit deeper than this is long here. All right, so we're going to bore the inside of this. We got about 200 thousandths to come out. An inch. This is my finishing pass, 22 thousandths. Found this stuff likes bigger bites. I took a really big bite and it was much happier. Much better surface finish. Like 100 thousandths, 50 thousandths a side. This is 23 total, so 10 thousandths a side. Surface finish is not great. You can already tell. All right. Yeah, that's a really good fit. That should be perfect. There's going to be a 3/8 spacer that goes right here between this gap. I've got to make that. And I've still got to make a 1/4 inch spacer that is the mounting. It's going to be welded to this piece that goes down low. But this is perfect. Time to move on. All right, that finishes up this piece. So we've got the press fit that's going to be welded on this side, and we've got the very close fit for the distributor on the top. Now we're going to make a flange that's going to fit around here, and another flange that's going to fit around here. Next up, we got this big old chunk of 1045 in there, and we're going to try and duplicate this flange here. And this flange is going to be minus that diameter because the bushing, that large piece I made that's got the press fit on it, is exactly this diameter. So this part's just got to fit over the outside of it. So first, we got to get it to proper diameter. So this is not round, but I took the largest dimension and it's about 3.6. So that's what we're going to shoot for here. So we're going to try and take 80 thousandths. That'll get us way under the mill scale. And we've got a pretty fast feed rate. Okay. Okay. Gave a really nice finish on that. That's pretty amazing. Take a really high feed rate and finish is shiny. This is not a critical dimension, so we're just trying to get close. So we got 120 thousandths to come off. Take that feed rate down to half. Not breaking chips. That yanked up all the chips out of the chip tray in there, and then I grabbed the wrong handle. Panic never suits you. Next up, we need to bore out the inside to a diameter that matches the outside diameter of this. So quite a bit of material's got to come out. So based on the way this is cutting, I think 1045 means it's 0.45% carbon, which makes it medium carbon steel. And it seems like it's kind of hard. So I'm not even sure how this is going to cut. Oh yeah, wow. It's cutting. It's definitely resisting. Oops. A little bothered by the non-symmetrical chips. Oh, I guess they are sort of, they're breaking on the bottom side. All right, there we go. It's my 1/2 inch. We only need to go up to 1.6. Correction, this guy needs to go up to 2.186 inches. We got a long, long way to go. I'm gonna see if I can jump to 1 inch. This may be a bit much effort for it, but hundred thousandths past this time. Breaking chips, I like it. 150 thousandths pass. All right, let's clean that up. Oh, that's nice finish. I like this stuff. Much better than mild steel. Cold rolled? Yuck. So I haven't even chamfered the edge. Let's see how it fits. I made it like a 1/2 thousandth over. Oh, yeah, there it goes. Look at that. And talk about the no wiggle fit. Okay, that's perfect. Alrighty. So what that diameter has given me is for the rear washer, because the rear washer is going to have that diameter for 3/8 of an inch plus another 1/8 of an inch of the larger diameter we're about to do now. So we're going to keep going. That was the first diameter. We're shooting for this diameter now, and this is a little over 2 inches. For this outer washer and part of the inner washer, we're just going to try and get it all in one pass here. 136. Okay, proof's in the pudding. This is my bad one, but it is the same size. Oh man, we're just really, really close. Look at that. That's like dead on. Let's try the actual part. see if this one might be a tiny bit smaller. Oh, look at that fit. Holy cow. That is a absolute, I nailed it right on. So we're gonna have to take off like 1,000 just to make sure you can slide it on. That was too close a fit. Pretty amazing. That's what I was trying for though. I'm trying to figure out how you can take a large cut and still end up on size. By the way, do you see the chips that this thing's producing? Neat stuff. And it's so funny, I was getting better finish taking big bites with this stuff. 150 thousandths total diameter off was better than this 1,000th pass by the looks of it. Alrighty. So this needs to slide down so they can weld it. That is a really good fit, so that's going to weld nicely, I think. So let's just chamfer it real quick. Then we can part off the 1/4 inch portion. And that should be good. We just want the tiniest amount off. And then we want to part this guy. Not a precision thickness. We want 1/2 inch approximately, 1/4 inch approximately. And the parting tool also is a little over 1/8 inch, so we'll be losing 3/8 of material here. Hopefully I compensated adequately. And hopefully the parting tool will leave a good finish so I don't need to reface the other side. It usually does. That turned out good. It's quite warm. Surface finish is pretty good. Hot, 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 hot. All right, so there's the first washer and or flange, and that will actually slide down on this guy. It's such a tight fit. I probably could have taken even a little bit more off. It's a perfect fit on here. So if you get it a little bit off angle, it sticks. But that's going to be slid down to some level and it's going to be welded in place, so this should make it really easy for him to weld. All right, now let's make this guy. Okay, now we just got to finish this part off, which actually is pretty perfect actually. So we just need I can face this off to get 1/8 inch material down here and then another 3/8 above. I decided to face this guy off and I'm going a really slow speed. Yeah, not great finish at all. It really wants a bigger bite. Well, interesting experiment. Slow speed or small depths of cut, and it cuts sort of like 10/18. Now we're going to part off the second one, and unfortunately we got to go through some of the scale. Boy, oh boy, we are really close, but I don't know if it's going to make it. It didn't quite make it. That's amazing. Guess we're gonna take this over the bandsaw and then face this guy off. So to get this disc straight in the chuck, I ran the lathe slowly and I took this tool I made that has a ball bearing in the end and ran it into the part at the very outside with the chuck not quite tight all the way, and it just straightens it right out for you within a few thousandths, and if it's not really critical, then this works quite well. All right, I'm going to show you the centering tool in action here. So one of the ways to get the part mostly square is you rotate it in place with the chuck mostly tight. And I'm going to snug the chuck but not tighten it all the way. And then we're going to run. Holy cow. Well, I didn't mean to be out that much, but all right. See how that works? And we're good. And I'm just doing this to demonstrate this, and I'm just gonna sand this part. You wanna see real quick how these parts go together. So this guy's gonna get 3 holes drilled in it. And it just slides down. Boy, it's tight. He's gonna have fun welding that in place because he's not gonna have to set up a clamp or anything. It's just gonna stay. I think I might need to just open that up a little bit. And then this one, that one goes down about halfway, and then this one fits right on top like that. And then into that, this will have bolt holes, threaded and tapped holes, and then into that will fit this guy. And there'll be some clamps that come out of the holes on this that allow you to lock the distributor in place. Alrighty, so there's more to do because the customer came back out and said he really liked what he saw so far, so he wanted me to make some more parts for this. So this guy sits on top here and it duplicates this part more or less, except you don't need these other mounting bolts for it. And so he wanted me to drill and tap these 2 bolt holes here on this guy. Those hold down clamps that position your distributor on there. And I was trying to figure out ways to find the proper bolt hole centering for this guy. And originally I was going to take these 2 bolts, these carriage bolts, and I was going to take and make a fixture to hold them in the vise very accurately, turn down the centers to very specific diameters on both, and then thread them in to here and measure across them. Well, it turns out I don't really need to do that. Modern manufacturing processes make even inexpensive bolts like this very, very accurate size-wise repeatably. And when I looked at this 3.370 across there, I thought, well, maybe the thread diameters are going to vary a bit, so I popped my micrometers on here. 0.36725, 0.36625, within 1,000th. It's amazing that modern manufacturing process can make a commodity item like this so accurate. So I'm just going to measure across here, subtract one of the diameters, and that's going to be my bolt hole circle diameter. And we're going to head over to the mill and we're going to drill and tap 2 holes in here with the 3/8. All right, so to find the center of this guy, I could have used the Blake coaxial indicator or my Chinese clone of that. But because I know the outside was turned concentric with the inside, because this was all one piece turned in one operation, I know that they're very, very coaxial, and I can trust the surfaces. So first thing what I did is I took my indicator and I measured between the 2 vise jaws and got dead center, and then went back and forth and made sure that I got exactly the same reading on both sides. Then I got my Y0 point, which puts me at the peak along the x-axis, and I went from side to side on the x-axis and again repeated, and here's my 0, and it repeated several times within 1/10, so I'm very confident that I'm on center here. And we're done. Just got to deburr the other side. There's the finished part, tapped and threaded.